This is the lecture for section 6.5, MEC 1105, College Algebra. So in this section, we're going to be talking about the properties of logs. So the first thing is that log base a of 1 is equal to 0. And then the log base a of a is equal to 1. And so this is important because this will allow us to solve equations later on. Now, before I get into these rules, there's certain things. So m, n, and a are positive real numbers. A does not equal to 1. R can be any real number. And then so a raised to the log base a of m is equal to m. And the log base a of a raised to the r power is equal to r. Again, these can be helpful to solve equations. The next thing is that log base a of m times n is equivalent to the log base a of m plus the log base a of n. And then the next one is the log base a of m divided by n is equal to the log base a of m minus the log base a of n. Here, the log base a of m raised to the r power. So the exponent here, we can make that a coefficient or a factor, so it becomes r times log base a of m. The next one is a to the r power is equivalent to e raised to the r natural log of a. So here we got a couple more rules before we get into the problems. So in this one, so if m is equal to n, then the log base a of m is equal to the log base a of n. Again, the reverse of that, the converse would be that log base a of m is equal to log base a of n. Then that means that m is equal to n. Sorry. And then the last one here, b is a positive number, does not equal 1. M and n are both positive numbers. A is greater than 0, positive number, and a does not equal 1. So the log base a of m, so this is what they call the change of base. So log base a of m is equal to the log base b of m divided by the log base b of a. So we can use any base to transform the log base a of m into a ratio. So the next one, the log base a of m, can also be written as a log of m divided by the log of a. And it can also be written as a natural log of m divided by the natural log of a. So for number 37, what they're asking us is to expand this. And so the first thing is I'm going to use, so this is the log base a, 25, plus the log base a of x. Now, the thing here is that I can say that the log base a of 5 to the second power plus the log base 5 of x. So if I go back to this one rule here, which is this one, right? So that will allow me to simply write this as 2. So this is going to be 2 plus the log base 5 of x. So remember, log base a of a to the r power is equal to r. So let's look at number 39. So number 39, we have log base 2 of z to the third power, which means that I can write it as 3 times the log base 2 of z. Just write that as a factor. So for number 40, we have the log base 7 of x to the fifth power. So we're going to just write that as 5 times the log base 7 of x. Number 41, we can write that as natural log of e plus the natural log of x. But remember, the natural log of e is just equal to 1. So then this is equal to 1 plus the natural log of x. All right, the next one's going to be number 49 that we have. And number 49, we're going to expand this one. So there are some restrictions. X has to be greater than 3, otherwise we'll try to divide by 0. And so here we're going to say that the log base 2, let me write it this way, of x to the third power minus the log base 2 of x minus 3. And so then the last thing that we can do is just write the 3 as a factor. So it's 3 times log base 2 of x minus the log base 2 of x minus 3. So the next one that we have is number 51. So here we have the log. I'm going to write this one, so it's going to be x minus the log of x plus 3 to the second power. So then this becomes the log of x plus the log of x plus 2 minus 2 log of x plus 3. And so that's the answer for number 51. For number 60 here, sorry, again, they're asking us to just write it as just having one log. And so then this becomes the log base 2 of 1 over x times 1 over x squared, which is just going to be the log base 2 of 1 over x to the third power, right? And that's number 60. So number 62, what they're asking again is to write it just as one log. So the first thing that I want to do is I'm going to say, okay, so the log of x squared plus 3x plus 2 minus the log of x plus 1 to the second power. And then this becomes the log of x squared plus 3x plus 2 over the log, over x plus 1 to the second power. And so that would be number 61. Now we can factor out x squared plus 3x plus 2, so it becomes the log, in this case, x plus 2, x plus 1 over x plus 1 to the second power, which just becomes the log of x plus 2 over x plus 1. All right. So number 71, what they're asking us is to rewrite this to try to evaluate it without a calculator. So I'm going to write the natural log of 21 over the natural log of 3. So if I write it that way, what that becomes is about 2.771. Right? So change it and then evaluate it, especially if you don't have a calculator that can do the different base. So here's the natural log of 18 over the natural log of 5, which is about 1.796. That's easier. Natural log is easier. Most calculators have the natural log key. And so then for 75, again, we get the, I'm going to write it this way. I'm going to say natural log of 7 over natural log of square root of 2, which is about 5.615. And that's the end of 6.5. Thank you.